Okay, sketching a few exponential functions. So on this first one, we have 0.25 raised to the x power. We want to pick out some information about this domain, range, horizontal asymptote, and some key points to get our graph going here. So as I think about this one, what I'm going to do is I'm going to visualize this instead of 0.25. An equivalent thing would be 1/4 is the same thing as 0.25 raised to the x power. So this is the same thing as our original f of x. It's just rewritten slightly differently. All right, so from this, let's identify some key points to begin with. So one key point is if I were to plug in 0, anything raised to the 0 power is going to equal 1. A second key point that we like to pick out is if we plugged in a 1, we just get that base back. We get 1/4 raised to the first power. However, because we have a fractional base here, a base between 0 and 1, what we want to do is we also want to pick out a third key point, or you could actually use this one instead of the 1 comma 1/4. And that's if we plug in a -1 up here in the exponent. Okay, what's going to get returned here is the reciprocal of this base. So instead of 1/4, if we flip that upside down, we get 4/1, or 4 as a key point. So I would go with these two key points, the 0, 1 and the -1, 4, just because graphing anything that's not an integer is going to be more difficult. So the 1 comma 1/4 is going to be a little bit more difficult. All right, so in plotting these points, we have 0, 1, 1 1/4, and then -1, 4. After you get those points on the graph, we have the general look of what's going to be going on here. Kind of connect these together. What's going to happen is this is going to get infinitely close to the x-axis, but it's not going to quite get there. So we can say we have a horizontal asymptote at the x-axis, or we designated that as y equals 0 as a horizontal line. We're allowed to plug in any values we want. So we'd say the domain is -infinity to +infinity. And then finally, the range. This is somewhat based on where the horizontal asymptote is, that it's getting infinitely close to the x-axis, or this horizontal asymptote at 0, but it never quite gets there. So our lowest value is almost to 0, but we're going to leave it out using the open brackets. And then over on the left-hand side, this goes up forever. So we'd say that goes to +infinity over here on the left-hand side. All right. The key points are really important as far as getting good graphs of these. All right, let's look at one more of these where we want to sketch 4 raised to the x power. Same information, looking for it. All right, so our key points again are plug in a 0, you always get a 1 back. This time, because our base is not between 0 and 1, it's a nice integer already. If I plugged in a 1, we get 4 to the first power. So we get 4 as a second key point. All right, in plotting these, we have 0, 1, and then 1, 4. And you'll get the hang of all of these exponential functions kind of have the same looking graphs. Just be careful about the key points. Either they're decreasing like this one at the top is, or they're increasing like the 4 to the x is that we just graphed. Now looking at this, we can plug in any x value again. And the domain for all of these exponential functions is going to be negative to +infinity. The horizontal asymptote, this time we get close to the x-axis over the left-hand side, but it's still y equals 0 for our horizontal asymptote. And then the range, it looks like we start at the x-axis or almost at the x-axis, but we'll leave it out. And it increases without bound over on the right-hand side. It goes up to infinity over on the right. All right, so I hope this helps out on identifying key points, domain, range, and horizontal asymptote, and getting nice little graphs of exponential functions. Good luck.